My name is Luke Seibold, and you're watching PhyziX. Today, we're going to be looking at motion graphs. Alright, so a way in which we can illustrate motion is by using different graphs. So first, let's take a look at a displacement time graph. So on the y-axis, we're going to have displacement, and on the x-axis, we're going to have time. So let's picture we have something that starts with zero displacement. It's at its origin, and then over time it starts to move further and further away from its origin as time goes on. So let's take a quick look back at our equation for velocity. So velocity equals displacement over time. So wait a second, we have displacement on the y-axis and time on the x-axis. So that means that the slope is the rise over the run, which is displacement over time. So that means that the slope must be equal to velocity because it is the displacement over time. So now let's imagine that this object has stopped. So it is no longer gaining or losing any displacement over time. So that's going to look like this. And because the displacement is 0 and the time is whatever this is, the velocity will be 0. So from this we can tell that it has no velocity and it is just a stationary object. Now if something were to be moving faster, it would have a steeper slope because it is going a further, it has more displacement in a shorter period of time. If the displacement was to go all the way back down to the origin, then it would again over this entire time period have a velocity of 0 because the displacement it traveled is 0 over this entire period, while the time is this, whatever this amount of time is. And from in this portion of the graph, we'll be seeing a negative velocity as the displacement, it will be a negative value. So we'll have a negative s over t, giving us a negative value for velocity. And this also shows the direction in which the object is moving. Because it's negative, it's coming back towards the origin, whereas before, when it was positive, it's going away from the origin. Alright, now let's take a look at a velocity time graph. So on the y-axis we have velocity, and on the x-axis we have time. So in this case, if something's velocity is increasing over time, let's say it started at 0 and its velocity is increasing over time, well then we have to look at a different equation. So in this case, the slope of this graph is the rise over run, which is velocity over time. And where have we seen that before? That's right, that's acceleration. So the slope of this graph would be its acceleration. So if velocity stayed the same for a little bit, then it wouldn't be gaining or losing any velocity. It would just be staying at this value of its velocity. So it would have constant velocity, meaning it stayed at the same velocity the entire time. And because the velocity didn't change, the v would be 0, and so acceleration would also be 0. Now if the slope increased, then again we have a greater change in velocity over time, and so a greater acceleration. And then if it decreased back down to 0, then the change in velocity over this entire period would be 0, and the acceleration would also be 0. And it would also then, in this portion of the graph, have a negative acceleration because the v was going back towards 0. So it would have a negative value, and this would also have a negative value. Now, unlike a displacement time graph, there's another aspect of a velocity time graph that we can look at to get a value. So if we go back to our other equation that we had for velocity, where velocity equals displacement over time, we multiply both sides by time, and we see that displacement is equal to velocity times time. And now from the graph, we see that if the y-axis is v and the x-axis is t, then the area underneath the graph would be velocity times time. So this aspect of the graph is actually given by vt, v, and t, which gives you the displacement. Now, this would be its displacement over this period of time. Now, if we were only to look at the portion of the graph up until this point of time, then this area would give you the displacement from 0 seconds up until this point t. Alright, now the final graph we're going to come across is an acceleration time graph. So we have acceleration on the y-axis and time on the x-axis. Now, the slope of this graph actually doesn't mean much to us. It is because we don't actually have an equation for acceleration over time. It does equal something called jerk, but you won't really come across what this is. But so let's say the acceleration is increasing over time, then it levels out again, and then it decreases. So one thing that we can determine from, first of all, let's just put a little note. That's jerk. One thing that we can determine from an acceleration time graph is velocity. Because if we look at the previous equation that we had before, acceleration equals velocity over time. If we multiply both sides by time, then we get acceleration times time equals velocity. So that means that the area underneath this graph, because the area is the acceleration times the time, the area underneath this graph is equal to the velocity over this time period from that point up until t1. Now again, if we go back to this point, then the area between 0 and, we'll call this t2, the area there, that would be the velocity over this time period. So as we can see, graphs can be incredibly useful in physics for determining how something is going to move.